All right, and on to the last section here, part 4 for chapter 2, research methodology. Now we're going to talk about how good research requires valid, reliable, and accurate data. Construct validity is the extent to which variables measure what they are supposed to measure. External validity is the degree to which the findings of the study can be generalized to other people, settings, or situations. And internal validity is the degree to which the effects observed in an experiment are due to the independent variable and not some other variable or confound. Construct validity. Here's an example of construct validity. Imagine having to answer questions like this on your psychology final. The results would lack construct validity because the course is about psychology, not chemistry. Here's an example of a study lacking internal validity. In this study, your entire population is one experimental group, which receives the treatment of special tutoring. You determine the group's average score on the final exam, but you cannot compare the result to a control group. This is an example of a study with internal validity. In this better study, you divide the population into an experimental group and a control group. Only the experimental group receives the treatment. You can then compare the results with the results from the control group. Reliability is the degree to which a measure is stable and consistent over time. Accuracy is the degree to which the experimental measure is free from error. A random error is the amount of error introduced into each measurement differs each time. And a systematic error is the amount of error introduced into each measurement is constant. This graphic is an example of a random error. Data accuracy can be affected by the random error. For example, say you time the same research participant several times. The stopwatch works accurately, but because your judgment of starting and stopping times differs each time, the degree of error varies each time. In this example of a systematic error, you time the same research participant several times, but the stopwatch is off by 1 minute each time. The degree of error is constant. Descriptive statistics provide a summary of the data. Descriptive statistics are statistics that summarize the data collected in a study. Contains information like central tendency. This is a measurement that represents the typical response or the behavior of a group as a whole. This consists of the mean, median, and mode. The mean is a measure of central tendency that is the mathematical average of a set of numbers. The median is a measurement of central tendency that is the value in the set of numbers that falls exactly halfway between the lowest and highest values. And lastly, there is the mode. This is a measure of central tendency that is the most frequent score or value in a set of numbers. Variability. In a set of numbers, how widely dispersed the values are from each other and from the mean. A standard deviation is a statistical measure of how far away each value is, on average, from the mean. Descriptive statistics can also be used to summarize how two variables relate to each other. A scatter plot. This is a graphical depiction of the relationship between two variables. A correlation coefficient is a descriptive statistic that indicates the strength and direction of the relationship between two variables. And in this case, it varies between -1 and +1, not greater or lower than that. Here are some examples of these scatter plots and what they mean. As I mentioned, correlations can differ between values of -1 and +1. These values reveal different kinds of relationships between two variables. The greater the scatter of values, the lower the correlation. A perfect correlation occurs when all the values fall on a straight line. Here you can see an example of the perfect negative correlation, which you will probably never see. More likely you would see a medium negative or positive correlation where it's the group of dots but they imply a direction. And then there's the no correlation, 0. Inferential statistics permit generalizations. Inferential statistics is a set of procedures that enable researchers to decide whether differences between two or more groups are probably just chance variations or whether they reflect true differences in the populations being compared. Results deemed very unlikely to be due to chance are statistically significant. Evaluating differences in research results. In this hypothetical experiment comparing two groups in a driving simulator, the group assigned to the texting condition had significantly more accidents. The result is reflected in the difference between the means of the two groups. Error bars have been added to show variability of the data within each condition. Meta-analysis. This is the study of studies that combines the findings of multiple studies to arrive at a conclusion. With meta-analysis, many studies that have addressed the same issue are combined and summarized in one study. Because meta-analysis combines the results of separate studies, many researchers believe that meta-analysis provides stronger evidence than the results of any single study by itself. Should you bet on a hot hand? The short answer is no. Misunderstanding statistics. Should you bet on a hot hand? In 2013, the Miami Heat's LeBron James set a basketball record by scoring over 30 points, while making over 60% of his shots for 6 straight games. Did James have a hot hand during this streak? Are there periods when particular athletes are relaxed, confident, and in the zone and play particularly well? Many sports journalists, coaches, athletes, and fans believe in some form of this phenomenon. If their belief were accurate, then an analysis of shooting records should show the increased probability of making a shot after previous successes than after previous failures. Researchers studied shooting records of the Philadelphia 76ers during the 1980 and 81 season. The data did not support the hot hand hypothesis. Additionally, players made about the same number of second free throws whether they made the first one or not. A meta-analysis of 22 published articles found no evidence that a hot hand exists. Why do people believe in shooting streaks? The best answer is that people are bad at recognizing chance outcomes. If a fair coin is flipped, most people intuitively expect there to be a greater alteration of heads and tails than occurs by chance. Just don't go for any chance outcomes or coincidences and those things, and you should be straight. Also, definitely don't bet on stuff like that. All right, and that concludes Part 4 of Chapter 2, Research Methodologies. Thanks for listening.